Okay, so let's look at example 9 here and put what we learned in the last video to work. And this will be the concrete that will show you how this works. It's one thing to read it and to try to understand the notation, but doing these will actually help you understand it. So let's take this matrix, a 2 by 2 matrix, right? So this is what it would look like, the representation of it. And so applying the definition of a permutation expansion, what we're going to do is we're going to go through the different permutations. There's only 2 of them, right? So permutation 1, right? We know phi of 1. So again, let's write this down just so we remember. So phi 1 equals 1 comma 2, and phi 2 equals 2 comma 1. So there's the 2 permutations. So by applying the expansion, we're doing t of 1, phi of 1, which is just 1. So phi 1, 1, t1, 1, t2, 2, and then times the determinant of the permutation matrix phi 1. Well, what is that? Well, we already found out what that was. So p of phi 1 is equal to what? Everything's getting mapped to where it is, so it's going to be what? It's going to be 1, 0, 0, 1. Okay? The permutation matrix for, well, hold on a second. Like that. Phi 2 equals 0, 1, 1, 0. Because it maps 1 goes to 2, 2 goes to 1. Okay, now, let's fill it in. So then what is it? It becomes t11 times t22, oops, times the determinant of 1, 0, 0, 1 plus t12, t21 times 0, 1, 1, 0. Okay. Now the cool thing is this is just 1. And this one we have to swap the rows, which makes it a negative 1. Right? And so now what do we get? We get t11, t22 minus t12, t21. And guess what? That's the same thing we get when we have A, B, C, D, right? It's A, D minus BC. That's what we got here. These two multiplied together minus these two. And so it matches. And we can show the same thing with the 3 by 3 formula as well. I'll leave that for you to practice doing, practicing with the notation.